Greetings and welcome to Mr. Van Loo's poorly monetized, low-budget science channel. Do not click subscribe. Today, we are going to analyze projectile motion with Logger Pro, and we're also going to talk about uncertainty. Okay, so first thing I will do here is insert a video, which you should have prepared ahead of time. So go to Insert Movie, and we will take a look at my videos. And there it is. Okay, so what we have here is a video of me launching a cotton ball. So there are a couple of things we need to do first to set this video up and prepare it. One, note that this is your scroller, which you're going to find handy as you work your way through the video. Okay? These two buttons here will step the video forward frame by frame, so very, very important. Okay, this button down here is how we're going to track our data points and set up our video for analysis. Okay, so the first thing we want to do to set it up is set our origin, which I am going to place right in the middle of my launcher, right there. And this will allow you to rotate the origin. And I want my origin to be parallel with my meter stick. So right about there. Okay, so you'll probably need to do that for your videos as well. Next, I need to set the length of my scale, and I'm going to do that using this yellow button right below the origin button. And what I'll do is I'll click the corner of my meter stick, which is going to be right about here, and then drag over to the other corner of the meter stick, and then I will set the length to 1 meter. Okay. If you're using a smaller device, such as a ruler, you'd use 30 centimeters or whatever other length you have laying around. Okay, so next we want to scroll to the actual action. So we're going to drag this over until my projectile's in motion. Okay, now we have a problem here kind of right off the bat. You can see here what I have is I have a kind of smear. I have some blurring in my video. If you have a really good high-speed camera, that's going to be less of a problem. But as you can see, this image is kind of grainy. Clearly, camera quality is not the best. So that's fine. We need to be able to deal with it quantitatively. Okay, so first what we're going to do is start tracking points, and I'm going to do that using this little red dot with the crosshairs. Okay, and for my first point, I want to put it right in the middle of this blur here. Okay, and I'm going to now do that for a few more frames. You'll note it progresses 1 frame at a time here, so that's convenient. Okay, next frame, and next frame, and next frame. Okay, we'll just do 4 points. If we wanted to be really picky about it, we would do the entire parabola, but I don't want this video to take any longer than it has to. Okay, so let's back up. So the next thing we need to do is measure the length of our blur. And we're going to treat the uncertainty of this point as an analog measurement, where the uncertainty is equal to 1/2 of the smallest increment. Okay, so we're going to treat this blur like the smallest increment of an analog measurement. Okay, so to do that, we click on our ruler here, and this is going to give us the length of the blur. If we wanted to be really picky about this, we could think about the horizontal and vertical components of our blur, but this value is going to be longer than either of those, and is therefore kind of a conservative way that we can approach this without doing lots of additional calculations. So it's just a time saver. Yes, our uncertainty on the X and Y axis will be larger than if we analyzed each axis independently. So this is it's a shortcut. but because we're being conservative, we can take this shortcut. Okay, so let's measure the length of our next frame. Just going for the length of the blur. And our next frame, again, going the whole length of the blur. And our next frame, and then it will stop boring you by measuring blurs. And you can bore yourself by measuring your own. Okay, so here we have 4 data points, and as you can see, our blur length is actually getting smaller. So what that means is, as we approach the apex of our parabola, we're going to have our smallest uncertainty, but there's still a bit of blurring, so we will still have relatively large uncertainty. If you had no blurring going on here, I think it would be fair to take half the diameter of your projectile and use that for uncertainty. Okay, so if you had a really good camera that wasn't blurring at all, or maybe better lighting, then this becomes less of an issue. Okay, so we have this data now, and the question becomes, what do we do with it? So first thing you're going to notice right away is that we have here a couple of things. So we've got our displacement on the x and y axis, and we're also given these columns for velocity on the x and y axis as well. You'll note that acceleration is not on here. We could manually add acceleration, but the problem is our uncertainty propagates through each of these measurements, and by the time we get to acceleration, it gets a little ugly. So, oops. All right, so what we want to do here is insert a new manual column. Okay, and we'll call this manual column double uncertainty. It's double uncertainty because this is going to be our smallest increment, okay, of, again, kind of an analog, what we're going to consider an analog measurement. Okay, so there is our double uncertainty. We're now going to enter our data from our video image for each of these respective points. So starting with 0.1480 meters. Or 0.1480, yeah, 0.1480 meters, and then 0.1464, and then 0.1257, and then finally 0.1207. You can see why I only did 4 points. Okay, so there we go. Now we need to add one more column, and we're going to go to data, and we're going to add a calculated column. This calculated column will be our uncertainty. Okay, and this will give us the size of our error bars, as you'll see in a second. Okay, so our expression here is going to be a mathematical expression, and we're going to take a variable out of this pull-down menu. So we'll choose a double uncertainty, and it just puts that in quotes, and that tells us that we're dealing with this double uncertainty column here. Okay, we're going to then divide these values from each cell in that column by 2. Okay, and when we click done, we will now have an uncertainty column that divides each of those by 2. Now, because this is a bit of a shortcut, but a conservative shortcut, we're going to set our uncertainty for both x and y values to that value. Okay, so the way that we do that is just by double clicking on the column, and that brings up manual column options, and you'll want the options tab. Okay, so we'll go then and check error bar calculations. And here we want to use the uncertainty column. Okay, so error bar calculations, tick column, and uncertainty column. Okay, we'll do that then for the y values as well. Double click, error bar calculations, use column, and uncertainty, done. okay? And now you can see our X and Y points both now have error bars, okay? So it's a little bit messy to have both X and Y on the same column. What we would see if we had more data points is that our Y values will be a parabola and our X values should be a straight line, in theory, a straight line. And of course, we would be neglecting error resistance for both of those to be perfectly true. Okay, you may find that it's better to clean things up and just put the y-axis on or the x-axis on. It's kind of up to you at this point. Depends on what you're doing. Okay, guys, so there's a quick and dirty overview of data collection and analyzing projectile motion with Logger Pro, and you now have a method for uncertainty, at least for position. If you wanted to get into uncertainty for velocity, you would need to propagate it, and you would want to look at topic 1.2 in your textbooks. I'm into another video on that at a later time, but not right now. Okay, so this has been Mr. Van Lowe's poorly monetized low budget science channel. Do not like, do not click subscribe, and have a really great day.